Good morning to all. Myself Chandana. Today I want to tell about formation of PN junction diode. Move to the topic. Before knowing the formation of PN junction diode, let's note what is semiconductors, types of semiconductors. Because because of the semiconductors formation, the PN junction is formed. Semiconductors. Semiconductors are material whose conductivity lies in between insulators and conductor. That is, conductivity is greater than insulator and less than conductors. There are two types of semiconductors. One is intrinsic semiconductors and number two is extrinsic semiconductors. Intrinsic semiconductors. A semiconductor is an extremely pure form of semiconductor is known as intrinsic semiconductor. Example, germanium and silicon. The crystal structure of germanium atom has absolute 0 Kelvin. Extrinsic semiconductors. An impure form of semiconductor is known as extrinsic semiconductor. Depending on the type of impurity added, the extrinsic semiconductor can be divided into two types. Number 1, N-type extrinsic semiconductor and number 2, P-type extrinsic semiconductor. N-type extrinsic semiconductor. A small amount of pentavalent impurity is added to pure semiconductor crystal. The resulting crystal will be N-type extrinsic semiconductors. Examples of N-type extrinsic semiconductors: nitrogen, phosphorus, arsenic, and etc. And P-type extrinsic semiconductors. Small amount of trivalent impurity is added to pure crystal, then the resulting crystal is of P-type semiconductors. Examples of P-type extrinsic semiconductors are boron, aluminium, gallium, and indium. Next, formation of PN junction diode. When a semiconductor is doped one half by P-type material and another half is doped by N-type material and PN junction is formed, the plane divide these two half zone is known as PN junction diode. The P-type material will have high concentration of holes and N-type material will have high concentration of electrons. As electron moved from N-type to P-type, the negative charge is built on the P side of junction and positive charge is developed on N-type. See, this is the structure of PN junction diode. See, this half part is P-type and this half part is N-type and the middle is the junction. So, total formation is PN junction diode. Biasing a PN junction diode. There are two types of biasing: forward bias and reverse bias. The depletion region might be golden, smaller or expand depending on the polarity and value of the applied potential. A diode made of the same semiconductor material is called homojunction. A diode made of different types of semiconductor material is called heterojunction. Without bias, there is no an external potential applied to the junction. Different components of charge carriers could be transformed in both regions. Two types of the majority carriers are available in the junction: electrons in the N-type region and holes in the P-type region. The minority carrier in the P-type and N-type regions are electrons and holes respectively. Due to gradient in the carrier connections, the majority carriers will diffuse in the opposite direction and the process is called diffusion process. The minority carriers will drift towards the P-type region and N-type region. The process continues until terminal equilibrium occurs in both sides of the PN junction diode. Forward bias. A PN junction is formed forward biased. A positive voltage terminal is connected to the P-type region and a negative voltage terminal is connected to the n-type region. The depletion region is narrowed because the majority carriers, which are electrons in the n-type and holes in the p-type, are forced to diffuse in the opposite direction. When the applied potential is more than built-in potential, a forward current can pass through the circuit. Reverse bias. The PN junction is reversed. A negative voltage terminal is connected to the p-type region. A positive voltage terminal is connected to the n-type region. The applied potential is less than the built-in potential. The minority carriers will be drifted towards the p-type region and n-type region. This process continues until terminal equilibrium occurs in both sides of the region. Thank you for giving this opportunity. Have a wonderful day.